Hi, everyone. So this is lesson 3, return of the inverse, logarithmic functions. And so our do now was right here. Oh, it's page 125. And yes, so if you notice on the do now, try to do it without, try to figure out what that question mark is and ignore all the purple, right? It's not there. And the question is just, what's the question mark, right? And take a look at the pattern, kind of, treat it like a puzzle, right? And yeah, pause. All right, so if you tried it out and you're like, okay, I think I got the pattern, maybe the numbers helped you and stuff. But what some people noticed was that, oh, they take the small number, and this 2 kind of tells you like how many times you multiply it by. So it's 5 to the second power, and that gives you this answer of 25, right? And if you notice like that, let's try this next, right? So let's try, let's make this black. So if we go 4, right here, 4 to the third power, and that gives us the answer of 64, right? Because 4 times 4 is 16. 16 times 4, I don't know if you knew that, but it's 64, right? So there we go. And then same thing with this one, 2 to the 6th power is 64, right? And then so then 3 to what powers? Do you see how that's in a rectangle? Like what power is that? 3 to something is equal to 81. Well, what could that be? And so somebody said, well, 4, right? Because 3 times 3 is 9. And then I take these two, 3 times 3s, they're 9. 9 times 9, 81, right? So here we know that the question mark is equal to 4. That's our lesson for today. Goodbye. Yeah, I'm just kidding. But I'm going to refer to this do now quite often. I did in class. I'm not sure if I'm going to do that in this video, but we'll see. So for today, the learning target is recognize the inverse of an exponential function as a logarithm. We'll talk more about that. What are logarithms? These, do you see the logs right here? The 4 logs? Yeah, logarithms. Logs for short. Identify the domain and range of logarithmic functions. I told you domain and range never leave us. They always will come back, right? Investigate graphs of logarithmic functions through intercepts, asymptotes, interval of increase and decrease, and end behavior. Yeah, again, so if a couple of lessons ago you were like, wait, what? We're doing it again. I told you, it just comes back. So hopefully your brain has had time to like marinate all that information in your brain. And now this time when you see it, hopefully there'll be some better understanding. So the question is, well, why do we even need this? Like, what's the whole point? So if I had given you a problem like 3 to the what power will give me 9, right? You'd be like, well, that's 2. So then you'd be like, oh, that's easy. But if I give you something like this, 3 to what power will give me 10? Now, all of a sudden, that's not so easy because we're like, well, I know if it's 3 to the second power, that's 9. But if it's 3 to the third power, that's 27. That's too big. But it's going to be somewhere between 2 and 3. And what is exactly is that going to be? That's where logs come in. That helps us find the exponent. So keep that in your brain. All right. So now, in the next page, page 126. There are 2 functions. And remember, this is called y is equal to x. Now, if you remember y is equal to x, where's that from? You remember this guy right here? And then we were like, oh yeah, when we're trying to do the inverses, we're like, oh yeah, with the x and the y need to flip. And so that needs to rotate. And then we need to change it like this, right? So that positive y is here and the positive x is here. Remember that? And so we're like, well, there must be a better way. And then so we had talked about that line, this line right here. So the y is equal to x. And if we just flip it on that line, it would look, that would be the transformation. That's what it would be. So it's just like a one-stop shop, one step, one and done, right? So that's this line right here, y equals x. That's our line of reflection. Line of reflection. I should probably write that down. So line of reflection. All right, so our function right here on the left, so they gave you the table for it already, so we don't even have to do anything. They already gave it to us. Our table, so I've tried to color coordinate, that's our blue. And our inverse function, so literally they took this table, and what do? They switched the x and y. Remember Freaky Friday, right? So literally they just flipped it, and so then they graphed it, and this is what they're getting right here. Do you see how it's reflected across that line right there? See? All right, so the green is inverse. So now I had asked the question, okay, we know that this function is equal to 2 to the x power. How do we know that? Because it says 2 to the x power, mind blowing. So we said, so if we know that this is y is equal to 2 to the x, so then if we were going to change it back to this form right here, what would that look like? What are you guessing? You know, what would that look like, right? And if you don't know, like, don't peek. So try and change it yourself, okay? And you did it. So what people said was like, okay, so it's gonna be log with the little 2 on the bottom, because that was like the thing that we're multiplying by, and then it's the y is what we was equal to, what it was equal to, is equal to x, right? That was whatever the exponent was, right? So that's so, and if you remember, so these two things are the same, right? We just changed the way it looked, right? So if you remember, the inverse is literally where we switch the x and the y, right? So if we switch the x and the y, right, we're going to just switch it right over here. So now it's going to be log 2, and then now it's going to be x is equal to y. That's what this, oh, I wrote it here. You see? So that's what this is. And then I just wrote it as the inverse in the function notation. So inverse of f of x is equal to y2x. I'll tell you how to say that, because that's not exactly how I should say that. But for now, since we don't know the verbiage for it, that's how we're going to say that, okay? So that's what that's going to be, okay? So do we need to know that? Not really, but it's a little intro into like applying what we just learned at the do now with this, what we're doing right now. So this is the graph of a log. I'm just saying, the log graph. It fell down. All right. So we're going to need this guy. So I just kind of copied and pasted right here so that we can see it all on one screen. You obviously, hopefully have a book, so you could just see it like right there. Happy days. You don't need to copy and paste. I'm just putting it right here. So, and if you did not already, I would like you to take the time to do the domain and, you know, range and all that. Do as much as you can. Okay. And then you're going to just push play, and then, you know, because you're not going to look at the screen and cheat, because we're not doing that. And then go from there. Right. All right. So I'm assuming that you've done all that. And here we go. So our domain for f of x, so the blue right here, is domain. Remember, it can be anything, right? It goes all the way to the left and all the way to the right. You see these arrows right here. So yeah, so it's all real numbers. So from negative infinity to positive infinity. Happy days. What's our range? How low does it go and how high does it go? Right? If you notice, it goes as low as like, it never crosses the x-axis, right? It like never crosses, ever, period, never. Right. So this one is going to be, it stops. So it's going to be from 0 all the way to positive infinity. And if you notice, that is a parentheses, right? A parentheses, because it doesn't actually touch 0. Remember, it never actually gets to 0. If you're just, because remember, this is 2 to the x power. So if it's like 2 to the negative 1, that'd be like 1/2. And then the 2 to the negative 2 is like 1/2 times 1/2. Right? If you keep on multiplying these halves, then what are you going to have? Something really close to 0, but is it ever going to get to 0? No, because like you just keep on multiplying by half. The only way we're going to get 0 by multiplying is if one of those numbers are 0. If it's not going to be 0, it literally can't be 0. So it'll get really close, but it can't equal it. That's what we call it. So that line, where you draw the line, that's the asymptote. Okay, so this blue line right here that you can barely see is the asymptote, which is y equals 0. Now, some may say, well, isn't it x equals to 0 because it's the x-axis? And I'd be like, well, it's a good point. Because remember, what is the value of x right here on this x-axis? And you'd say -8. Well, what about right here? -6. Do you see how it changes depending on my location? So x is not equal to 0 here because x is equal to whatever this point is, right? But what about the y? So this is -8, 0. This is -6, 0. This is -5, 0. Notice what still stays the same, the y. Y is always 0. Why is y always 0? Because we're staying on the x-axis. It's not going up or down. So therefore, y is equal to 0. That's the equation of the line, y equals to 0. Does not matter what x is, because it's just, y is just 0. All right, so now that we've cleared that up. So is it interval of increase or decrease or both, or some combination of that? If you look at this, remember, we're always going from left to right. Imagine it starts all the way here from negative infinity, and it just kind of keeps on going. Remember, it's barely going up. It's very incrementally small, going up and up and up until we, but it's, again, continuously increasing. It is never, ever decreasing. Okay, so it is increasing from negative infinity to positive infinity forever and ever. Remember, interval talks about our x. So this should be very similar to our domain here. Do you see? Yeah. And then so if you, and then so there's that, always increasing. And then so for our, what is it called? Our end behavior. So if as x approaches negative infinity, so we go more and more left, what is y approaching? It's like it's coming down like an airplane. Y is approaching not negative infinity because it never goes down here below, right? It approaches actually zero. It's really, really close to zero. Where have I heard zero before? Asymptote, yeah. So yeah, so this approach, so f of x approaches zero. If f of x confuses you, then just use y to say y approaches zero, okay? And then as f of x gets really, really positive, so the more right we go, what's the graph doing? It's doing one of these, right? It's going way, way the heck up there, right? So that is approaching positive infinity as well. And then let's try now the green part, right? The inverse. So remember what we talked about the domain and range when we're talking about inverses? It doesn't, if we switch the x and the y, then doesn't it make sense that the domain and range also flip, right? But let's get some like understanding around that, right? So if we're looking at the domain, if we're looking at the green, right? It seems like it never crosses that y-axis, right? Which would be true. It's true, right? Just like how it never crossed the x-axis here, it never crossed the y-axis here. So it's from zero, or I should say zero to positive infinity. All right, so zero to positive infinity. Oh, look, that's what the range was. Now it's the domain. Weird, right? Coincidence. And then about the range, now notice it has an arrow that goes down and the arrow goes slightly up, but it's up. It's like northwest-ish, but it's still north, right? So it's still going up. So that is going to be from negative infinity to positive infinity. All right. And then notice our y-intercept, yeah, we don't got none. It can't touch that y-axis. That's the electric fence, right? But we do have an x-intercept. So we just put that in there. We technically don't need to write that in, but we're putting it in because we're like, hey, it does have an intercept, right? Which is at 1, 0. And notice y-intercept was 0, 1, and now it's 1, 0. It flipped. Weird. Right? So it's right there at this point, 1, 0. And then the asymptote, of course, is going to be this right here, the y-axis, which is x is equal to 0, because that's where x is always equal to 0. See how this makes sense? So there's x equal to 0, and it is increasing. Now, some people be like, wait, isn't it supposed to be decreasing? And I was like, I thought that too. I'm like, it's decreasing. Wait, no, it's not. Remember, we're going left to right. So if we're going left to right and we're doing this, is this going up or down? Well, it's not going down, I'll tell you that much, right? So definitely not going down. But what you're like, well, then what's flipped? Okay, so let's think about this. So look at the blue, the original, the OG original graph. And notice it's the speed of it going is very slow. It increases very, very slowly, right? Increases very, very slowly, but then all of a sudden, really super speeds up. So it increases really, really slowly. And then it just like, boom, very fast, right? Lots of growth at the end, right? Or not at the end, but like more you go to the right, I should say. But then if you look at the log, right? The inverse, right? We're like, it shoots up really fast and then it slows down, the growth slows down. So it's like trickling up, right? That's what's going on. So that switched, that rate switched. Okay, not that it's now increasing, now it's decreasing. It's not doing any of that. Okay, which is weird, I know, but you know, that's what it is. Okay, so there's that. Okay, oh, and it's going from, again, 0 to infinity. 0 to infinity. Remember I told you how to do with the domain? Yeah, that's what that is. Okay, so from 0 to infinity, it is just increasing. It is always increasing, but remember the rates are just different. Okay, and then the end behavior. So as x approaches, and I initially wrote down negative infinity, but I was like, wait, x is never going to go to negative because it can't even cross the y-axis. So therefore, well, how far left can I go? Oh, 0. Well, as x, and then remember, x does not ever get to 0. So that's what we say as x approaches 0, right? As x gets closer and closer to 0, 0.000001, right? What is f of x doing? Well, it's getting closer and closer to, it's going down, right? It's getting closer and closer to negative infinity. There we go. And as now we can say as x, because it does go right? So as x approaches positive infinity, what is y doing? It's also going up, right? So it's going to approach positive infinity. Better? Rewind? Do it again? I can do it again. Well, you can just rewind me and then I'll do it again. All right. So please make sure you box this because it's super important. Logarithms are exponents. That's all they are. Logarithms are exponents. So if you look right here, remember in our do now, those, what were these logs equal to? The exponent, right? Exponent. So what was that question mark? The exponent, right? So there we go. All right, so if you want to highlight this little thing right here, it says the logarithm of a number is the exponent to which the given base must be raised in order to produce the number. Huh? It's just basically, well, this is what it is. Okay, it's just the exponent. Okay, that's all. It's just the exponent for the, it's the answer. Anyways, let's go into this. Okay, so if you look at this, we're going to get the actual vocabulary for this now. So this little 2 is no longer called little 2. It's called the base. Because where's the base? At the bottom. So do you see how it's like a subscript at the bottom? And notice, remember in our exponent, because go back to our do now, right? Remember how we would have written this, right? We said it was 2, and this number out here would give us the exponent, like how many times we need to multiply the 2 by itself, right? Is equal to 8, right? This is how we would have written it. Now remember, for the exponent, we said, well, this is also, we call this the base. So that's the base. And this 3, yes, we call this the exponent. Notice here, you can either say exponent or log, because remember, logs are exponents. We can literally say equals, because R is and is equals. So logarithms is logarithm is exponent. Okay, so same thing. And then the okay, I don't know why it's called an argument, but it's the argument. That's just what they're saying. Not that I'm trying to fight with you. There are no arguments here except for 8. Okay. I ate the argument. All right. So if the way you say this, and I put this in quotation marks, right? So this is log base 2 of 8 is equal to 3. So literally you can do this with anything. So if I said, honestly, I don't know what this is. Because I don't know. So we would say log base 3 of 10 is equal to x. Do you see how that works? Okay, so that's how you would say that. All right, and so these are just, again, just like how we had it for last unit, we talked about radical form and exponential form. Well, exponential has another form. Did you know that? So it has exponential form, and now it has log form. So we're going to go in between those two. Okay, so I'll ask you, oh, write this log in exponential form, or write this exponent into log form. Same thing. Okay, it's just they equal each other. It's just a different way of looking at it. Again, just like I said before, it's like fractions and decimals. Same thing, just in a different form. Okay. All right. So there's a couple of different ones for you if you want to practice them. Honestly, what I would do is I would take a piece of paper and put it over here and be like, oh, not going to look at this. And I'm going to just change these all to log form. So I'd be like, okay, so y equals b to the x power. So let's try this out. So log, what is my base? B, and then it's to the, you remember the argument is equal to the exponent, x for exponent, right? And then I would like uncover this part with my paper and then just be like, oh yeah, I got it right. Or no, I didn't get it right, whichever one, right? And then you just correct it from there. And then you do the same thing for these ones. But don't worry, we have more places to practice this. But that's just my recommendation to you. All right. So now you're like, well, what if I don't remember how to do this? Like, that's kind of hard to remember all that. I'm like, I know. And shoot, one of my classes, we didn't do the restrictions. Darn it. So hopefully they're watching this video. All right. So here we go. So in the book, they call it the triangle of power. And honestly, I'm like, I don't understand what this means until like last year. more recently. So this is how I like to think of it. So the triangle of power, so literally if you write 2 to the third power is equal to 8, right? Because 2 times 2 times 2 is equal to 8, right? And do you see how it makes a triangle? Yeah, so a triangle like this, right? So now this is A, B, and C. And notice like when you do the log, it's in that exact order, A, B, C. So, and somebody showed me this, so I was like, I think this is cool. So this is 2, what is it? I can't talk. 2 to the third power is equal to 8, right? So we're going in this clockwise direction. So now if you want the log, you're going to have to go in the counterclockwise position, right? A, B, C. So that's going to be 2. So log base 2. So we're starting same place, 2. Base 2 of 8 is equal to 3. You see how that goes? So counterclockwise. So counterclockwise would be the log, and clockwise would be the exponent. However way you want to think about it. There's another way that I've been teaching since, like I looked on Pinterest like a couple years ago, and I was like, ooh, this is cool, because my teacher had said, just memorize it. And I was like, okay. And so if you're like, but I was like, I love this way because this is more satisfying to do. So if you, whichever way, if you want to do it with the power triangle of power, or if you want to do it with the E, that's fine. I don't even care. This is just a trick to help you understand the thing, right? To rewrite stuff. That's all. We're just trying to rewrite. So it says to write an exponential form, see the E for the exponent. Remember, because E starts with exponents. So we're going to start with 8 to the 3 power is equal to 512. We write 8 to the 3. So whatever you touch first, that's what you're writing. So 8 to the 3, and then is equal to 512, right? And this only works if your argument is on the right. If it looked like this, where it was like 3 is equal to log base 8, 5, yeah, this is not going to be, you can't, like this would be bad days. You would definitely write it wrong. So you'd have to make sure that your exponent is over there on the right. And exponent, because 512 is my argument. Oh my goodness, I may have said that wrong in the video. Ignore that part, okay? That's the exponent. Some of the vocabulary, like argument, I never learned about argument. So, we'll just learn together, right? I mean, I knew about it. I just forgot. Okay, so if you take a look at this one and you do the L to see the log. So this one again, so you start the L right here. So log base 9 of what? Of 81 is equal to 2. All right, that's how you do that. So let's do some practice, all right? Oh, before we get there. So this one right here, so this is 2x and 3, right? So they wrote down 2x and 3. So the way I like to think about it is 2 to the 3 power is equal to x. So 2 to the third power equal to x. If you notice right there, they said x equal to 8. You're like, yeah, that would totally make sense. And then let's try this one. Well, what about this? Is 2, so 2, 8x. So 2 to the x power is equal to 8. Right? So, and then this one right here, x 83. So x 83. I feel like that's a sentence. So this is x to the third power is equal to 8. Right, which would mean that this would have to be 2. But anyways, but yeah, this is how you would write an exponential form, and this is what the triangle would look like. Then let's do some practice here. So what I would do is for this is page 129, just pause it and do A through C. And if not, all right. And then, so now that you've done them, here, there, all we're doing is rewriting. We're not solving for X. A lot of people are like, ooh, I know what X is. Like, that's not what I want to know. I want to know if you can just change this to exponential form. That's it, right? And so again, it's, so right here, if we do the E, so 10 to the X power is equal to 1,000. 10 to the X power equals 1,000. Whichever way you want to think about it, whether it's the triangle of power or the E, that's okay. Or you just like, if you look, remember back to the do now, you're like, oh yeah, I just figured it out, so I'm just going to use that. Do that. I will not stop you. Okay, as long as you're doing it the right way. then we're good. And if you notice the colors here, I try to color coordinate them so that it's a little easier to see. So again, 5 to the 5 power is equal to x, right? And then, so these two statements are the same thing. These equations are the same thing, right? It's just, remember, we're just changing the way it looks. And again, x to the 1 power is equal to 9. In this case, I just wrote down the arrows, whichever way helps you to about it. All right, and so this one right here said convert to logs, right? So I just made these problems up. So these are not in your book. I like just try these out, right? So again, so log, so here we're gonna see the L. So log base 3 of 15 is equal to x. This I don't remember as much. Honestly, I can just do the E here, right? Because if you really want to, just log base 3 to the 15 or of 15 is equal to x, right? You can still, or as somebody called it, the loop-de-loop. You can totally do that instead, it doesn't matter, right? Or if you want to do the triangle, so a to the m is equal to n. So it's going to go in the ABC form in the opposite direction, you know, the inverse, right? So it's like this. So log base a of n is equal to m, which is the exponent. Because what are logs? Exponents. All right. That's the end of the lesson. So we'll go on and do more. So the graphing logarithmic functions will be tomorrow or the next lesson, whichever, I don't know when you're watching this.